Welcome to another video of CAD and Sorcery, fellow designers. Performance is something every SOLIDWORKS user cares about, especially as models start to grow. But very often, performance issues come from small details. In this video, we'll take a performance-focused look at threads in SOLIDWORKS and see how parts like bolts and screws affect assembly performance when they are fully modeled or simplified. We'll compare a modeled thread, a cosmetic thread, and a swept-cut thread, and see how each one affects rebuild time and assembly performance. If you work with large assemblies, this difference really matters. First, let's create a bolt using the thread command. You can access the thread command from the arrow under the Hole Wizard tool. This command allows you to create a fully modeled thread directly on your part. Simply select the circular edge where the thread should start and define an offset if needed. You can choose between blind, revolutions, or up to selection as the end condition. Next, select the thread specification from the drop-down list. For this example, I'll use metric die size M10. Now that the thread is ready, let's run performance evaluation and check the rebuild time. As you can see, this part takes 0.52 seconds to rebuild, and the thread feature is responsible for most of that time. Let's repeat the same design using the cosmetic thread command. A cosmetic thread is only a graphical representation of the thread. No actual geometry is cut. Think of it like a visual wrap around the cylinder. First, select the circular edge where the thread should begin. Then, choose the standard, type, and size. I leave it at unsymmetric M10 and set the thread length to 25 mm. You can of course use different end conditions if needed. Let's confirm the command. As you can see in the graphics area, the thread appears visually and remains visible as long as display annotations is enabled from the annotations folder. Keep in mind that the cosmetic thread feature is nested inside the boss extrude feature. From there, it can be hidden, suppressed, or edited at any time. Now let's run performance evaluation again. This time, the rebuild time is only 0.06 seconds. That's approximately 88% faster than the fully modeled thread. This comparison isn't limited to the thread and cosmetic thread commands. The same logic applies to threads created using swept cut or similar methods. Here, I've modeled the same bolt once again, this time using a swept cut thread. The rebuild time for this version is 0.24 seconds, faster than the thread command, but still significantly slower than the cosmetic thread. So, comparing all three versions, the cosmetic thread is the fastest, followed by the swept cut thread, and the thread command version is the slowest. From a rebuild perspective, the difference is already very clear. Now, half a second might not sound like much until you place dozens or hundreds of these parts inside an assembly. This is where graphics triangles come into play. Modeled threads create far more triangles, which means smoother curves, but also slower graphics performance. And this applies to Toolbox components as well. In this example, I'm using the same unsymmetric bolt with three different display options: schematic, cosmetic, and simplified. Using assembly visualization and selecting graphics triangles as the property, we get the following results. That means that the schematic version has far more graphics triangles than the simplified one, effectively lowering the assembly performance. To conclude, when working with threads in SOLIDWORKS, performance-wise the safest choice is to use cosmetic threads, or no threads at all, especially in large assemblies. That way, you get cleaner graphics, faster rebuilds, and a much more responsive assembly without sacrificing clarity or documentation. I hope you liked this video, and if you did, don't forget to hit the like button and subscribe to my channel for more SOLIDWORKS content. I'll see you in the next video.